So I've got to be honest, prime factorization is probably one of my favorite things in the entire world to do in math, which I know is a very heavy sentence to say, but if Mrs. Thomas is honest, she loves prime factorization, and I really hope you like it too. It's simple, it's fun, there are simple steps, and you get to create a little number tree at the end of this activity. So just a quick rundown of what a prime number is. A prime number is a number or numbers whose only factors are 1 and itself, nothing else. So it can't be divided by 2 or 3 or 4 or 5 or 6 or 7 unless the number is 2, 3, 4, 5, 6, or 7. So some examples of prime factors or prime numbers would be 2, 3, 5, 7, 11, 13, and 17. Those are just a few of the most popular examples of what a prime number is. The reason I'm going over this is because prime factorization does just that. It takes a number and it breaks it down into its smallest prime numbers possible, and it can't be divided any more. So let me show you what I mean. So let's start with the number 18. I'm going to box my number 18, and I'm going to start by picking two numbers, any two numbers that I want, that if they multiply together, they equal 18. So I'm going to take 18, and I'm going to start with 9 and 2, because 9 times 2 gets me to 18. I'm going to ask myself, is 9 a prime number? Is 2 a prime number? Can either of them be broken down even more? So the number 2, like we just did on the first page, is actually a prime number. So I would circle that, and I'm finished. I can't break down the number 2 anymore. But my number 9, I can. There are two numbers that I can think of that can be multiplied together to create the number 9. And that would be 3 times 3. 3 times 3 gets me 9. My question again is, can I multiply anything else, or can I break down the number 3 anymore into two different numbers without just multiplying by 1? And the answer is no, because 3 is a prime number. So I'm going to circle the number 3. Circle the number 3. That number cannot be broken down anymore, so my factor tree is complete. If I wanted to write it in exponential form, what that means is I'm just taking my 3 prime numbers that I broke down the number 18 into, and I'm multiplying them. So my exponential form would be, take this 3 times 3 times 2. And that would be my exponential form, and that is a factor tree. Pretty simple. Let's try another one. Let's try it with the number 27. What's really important about these trees is that you know your multiplication facts. If you don't know your multiplication facts, this might be a struggle for you. So 27. I know the number 27 can be multiplied by 9 and 3. 9 times 3 gets me 27. Again, I'm picking any two random numbers that can multiply together to get 27. And in this case, there are no other numbers that we can multiply except for 9 and 3. So I'm going to ask myself, can 9 be broken down even more? Or are there two numbers that I can multiply by 9? Yes. Can I multiply anything else to break down to the number 3? No, because 3 is a prime number. So I'm going to circle 3, and that will go into my exponential form. And then I'm going to take the number 9, and I'm going to break that down into 3 times 3, because that's what multiplies together to get 9. 3 times 3 gets me 9. Can I break down the number 3 anymore? No. Those are both also prime numbers. So I'm going to circle those, and they also go in my exponential form. So my answer would be 3 times 3 times 3, written in exponential form. Now these are some pretty simple prime factorization trees. So let's try the number 36. I want you to pause this video, and I want you to try this prime factorization tree on your own. Either write it on a desk or on a scrap piece of paper, and then replay the video and continue watching. Okay, so if you were watching at this time, you already completed your prime factorization tree, and we're just double checking to see if you got your answer correct. So here we go. I'm going to do blue this time. I'm going to take the number 36, and I'm going to start with 2 random numbers. And I know that 6 times 6 gets me 36. I could have also done 18 times 2. All right, so I'm going to do that over here. I'm going to show you that there's 2 different ways to get there. So you could have chosen 18 times 2, because 18 times 2 also gets us 36. So let's see if we can get to the same answer. So here we go. 6 I know can be broken down even more. I can multiply 3 times 2 to get me 6, and I can also multiply 3 times 2 to get me 6. Over here, I know 18 can be broken down into 9 times 2. The number 2 cannot be broken down because that's a prime number. I'm going to hop back over here to my 6 and ask myself, can 3 be divided by anything other than itself and 1? No. So that is a prime number. Here, I'm actually going to draw it. There we go. Prime number. 2 is also a prime number. 3 is a prime number, and 2 is a prime number. So my answer would be 3 times 2 times 3 times 2. Now let's double check to see if this would get us to the same answer. 2 is a prime number, and I know 9 can be broken down into 3 times 3. So my answer is 3 times 3 times 2 times 2. And look at that. Same exact exponential form. So whether I chose 18 and 2 as my first numbers or 6 and 6, I get the same exact answer. So when I say you can pick 2 random numbers, I literally mean any 2 numbers that you know that equal the number 36. So let's try some practice on your own. So I'd like you to get the prime factorization practice worksheet over on the side table, and you are going to complete that worksheet with a partner of your choice, or if you would like to work alone, you may, and do some more practice with some prime factorization trees. If you would like a marker and a homemade whiteboard, just ask me as you do your work. If not, you can just do it on a scrap piece of paper and a pencil.